Artificial intelligence is often broadly used as an umbrella for various technologies and methodologies, including machine learning, deep learning, and generative AI. However, AI is better thought of as a field that combines many different areas of study, similar to how mathematics or physics do. In the constantly growing field of artificial intelligence, there exists a complex series of technologies, each one embedded within the next. One of those technologies is large language models, a subset of deep learning. Large language models, also known as LLMs, are specialized deep learning models built to grasp, produce, and engage with human language. These models undergo training using extensive text data, enabling them to execute a wide array of language-related tasks, including translating text, answering questions, and generating content. Large language model technology encompasses three primary types, each with its distinct functionalities and applications. Base language models are models that are designed to predict the next word in a sequence based on their training data. An example of this could be the prediction of the next word in a sequence like cat in the, where the model might predict hat based on the patterns it has learned during training. Instruction-tuned models are models that undergo additional training to better respond to specific instructions or queries. A question for such a model could be, what is the capital of Canada? This category also includes models enhanced through reinforcement learning from human feedback, also known as RLHF. This technique fine-tunes the models based on human feedback, improving their ability to follow instructions and provide relevant, accurate responses. Dialogue-tuned models are tailored for interactive conversations. These models are adept at engaging in dialogue, effectively mimicking conversational partners. They are the foundation of various conversational bots designed to provide users with a seamless and intuitive chatting experience. These models are specifically tuned to handle the nuances of human dialogue, making them ideal for applications in customer service, virtual assistants, and interactive entertainment. Each type of LLM serves a unique role with the broader ecosystem of natural language processing, offering specialized capabilities ranging from simple predictive typing to complex nuanced conversations and instruction task performance. LLMs are designed to perform a wide range of natural language processing tasks without task-specific model architecture. As you scale up with the size of the model in terms of parameters and the amount of training data, LLMs tend to exhibit improved performance on a wide range of tasks. However, with more parameters added to the model size also increases and more computational requirements and potential environments will be needed. LLM's capability is typically demonstrated in two contexts: zero-shot learning and few-shot learning. Zero-shot learning tests whether the language model can use what it already knows to do new tasks it hasn't been taught about directly. This means it doesn't need examples of specific tasks it's doing right then. Instead, it relies on the general knowledge it learned from studying lots of different topics before. In contrast, few-shot learning means the language model is given just a few examples of what it's supposed to do before it tackles a new task. These examples act as temporary guide, enabling the model to better understand and adapt to the specific requirements of the task at hand. For example, you can give a prompt that begins with the following: this is awesome, positive, this is bad, negative, this movie was good, positive, what a terrible movie. The language model will give you an answer of negative. There exists two distinct categories of large language models, namely open source and closed source variants. Open source LLMs are publicly available for researchers, developers, and companies to use, modify, and integrate into their projects, fostering innovation and collaboration within the community. Examples of open source large language models include Meta's Llama, Mistral's AI's AX7, and Stable Diffusion's by Stability AI. Conversely, closed-source models developed and controlled by organizations like OpenAI with models like GPT are proprietary with restricted access to their underlying code and training data. Closed-source models encompass offerings such as OpenAI's GPT, Google's Gemini, and Anthropic's Claude. A large language model is commonly composed of two primary components: a sizable parameters file and a execution code for operating the LLM and processing the parameters file. Interestingly, an LLM is capable of running on laptops without access to the internet. The parameter count in a parameters file essentially is a segment of the internet, varies widely from 125 million to 175 billion parameters as seen in the ChatGPT 3.5 model, or even reaching 540 billion parameters in the PaLM model. It's essential to note that the complexity and versatility of the large language model directly correlates with the parameter count. As parameters increase, so does the model's capacity to handle a broader range of tasks. To process and interpret the vast amounts of data from the internet and generate the LLM parameter file, a cluster of servers equipped with specialized processing units called GPUs is typically required. Large language models represent the complexity and innovation within artificial intelligence. These models, characterized by their massive parameter size and extensive pre-training, offer versatile capabilities from predictive typing to nuanced conversational engagement. Whether through zero-shot or few-shot learning, LLMs showcase their adaptability across tasks with minimal training data. The distinction between open source and closed source variants highlights collaborative research while acknowledging proprietary advancements.